Okay, 4.2 is fairly lined up and knocked down in example 1. So I'm going to go through working out example 1 on page 150. Now, before I get there, one thing I want to stress here is you have to be careful that you're not looking at infinitely many solutions where the lines actually go over each other. And we did that a little while ago. And you have to be careful with no solution, which means they're parallel. Mathematically, you should be able to discover if these are both equal statements. All right? Because we're going to use both of these statements to solve using a method known as substitution. Now, you might think substitution was what we did in example 4. On 4.1. We didn't. We really didn't. This is substitution. There's some facts given to us here in these two statements. Now remember, we're waiting to see where these two lines are going across each other. That's our solution. But we can't do that right away because we've got different languages here. We've got different types of formulas. Now you might think, oh no, I got to go back and I got to change this one to y equals mx plus b to be able to see how that's going to graph out. No, not yet. This is much easier to do another way. Now, so what this tells me is that I already know what y is equal to. Y is equal to 6x plus 7. Once again, just like we just did in 4.1 example 4, we're going to use the values of x to solve for x. Now, because now I know when I come to here, and I want to make sure I wrote this formula right. Yeah, I did. My formulas are right. I can take this amount and plug it in right here. Now what that's going to look like is this. Now I have 3x minus 8 times 6x plus 7 equals 4. Wrap your head around that, because that has to be true if y is equal to 6x plus 7. Do I see any y's over here? No, I'm solving for x. Solve for x. And that's how we get there. Now, right now I could stop this, but I want to go through this entirely because I know the kind of problems we have, or problems we have had. So now at this point, I'm looking at this and I'm saying, oh, okay, well, I got to do this, right? Now remember, we've got a lattice method to do this. We have a lattice method to do this. And before we get to that lattice method to do this means that we have to underline each one of our elements. So the lattice method to do this, for me at least, 3x on one side and whatever negative 8, let's back up. Hang on a second, I don't want to get too wrapped up there, so let's do this in a simpler form. We'll talk about lattice multiplication in the future, but it's better than this mess. All right, so now we're not going to touch 3x. Negative 8 times 6x is negative 48x. Whew, there's a big one. We're coming up on it. And negative 8 times 7 is negative 56. Still, I kept all of my elements, so I know what's positive and I know what's negative. Check your math, make sure that's what you see. Now it looks worse than it is. Now we're going to add 56 to both sides. Getting rid of this 56 on the left. And that will get us to 3x minus 48x equals 60. Are we okay? Check it out, look at it, see if it makes sense to you. So in my estimation, 3x minus 48x, right? Number line, number line, number line. I'm going to add 48x here. Just stay with me for a minute. Because I want to show you that you can't really get in trouble if you use the rules. So now I have 3x equals 48x plus, come on now, 60. That looks easier to work with. Because now I know I'm going to divide both sides by 3, right? Divide both sides by 3. And we get x equals 48 divided by 3, 16, right? 16 plus 16 plus 16, 16x. 60 divided by 3, is 20. Now it looks like I messed myself up here, but actually if I just keep going on, I should be okay. And I want you to see these things and how they work. Because this is negative 15x equals 20. So x equals negative 4/3. And if we know x is equal to negative 4/3, then our intersection becomes negative 4/3 and whatever y is. Solve for y. Check the formulas. When you check the formula, and by the way, when you solve for y, y actually equals negative 1. So we'll have negative 4/3, negative 1 as our answer. Okay, and that is example 1 in the book, so you can look at it there. I know seeing me do it can sometimes break the ice in regards to being able to do it, and now you'll have this copy over and over and over and over again if you want to look at it that often.